In this video, I'm going to show you a few examples of sine and cosine sum and difference identities and how they can allow you to find different trig values by hand that we didn't know how to find before. So based on the unit circle, we can find sine, cosine, tangent to values like 30 degrees, 45 degrees, 90 degrees, 270 degrees, and any other kind of angle that would use those angles around the unit circle. So, 135 degree angle, that sort of thing. However, we don't know how to find angle measures that don't directly tie into 30, 60, 90, 45 degree angle measures. Well, we actually can use these sum and difference identities to find exact values of things like the sine of 75, okay? The idea is it has to be an angle that's a sum or a difference of angles that we know how to find trig values for. So for example here, 75 degrees is 30 plus 45, okay? So I could rewrite this using the sine sum formula, and I could find the exact value of this. And it doesn't matter, you'll get the same answer whether or not you do 30 and 45 or 45 and 30. But anyway, to find the sine of 75, sine of 75 is going to be the sine of 30 plus 45, okay? Showed in an earlier video, I can't just take the sine of 30 and the sine of 45 and add the two together. It's not that easy. But here's what the formula tells me. The formula says I can take the sine of the first angle and multiply it by the cosine of the second angle, and then add the sine of the second angle times the cosine of the first angle, okay? So that's what we're going to do here. So I'll substitute in. That's going to be, in this case, this will be my alpha, this will be my beta. So it's going to be sine of 30 and then cosine of 45 plus sine of 45 cosine of 30. Okay? And that's a statement that'll give you the sine of 75. I'd like you to actually try to evaluate the statement, okay? And using the unit circle, hopefully at this point you've got a lot of these values memorized, but using the unit circle, you should be able to fill all of these in pretty easily. So the sine of 30 is equal to a half, okay? We're going to multiply by the cosine of 45, which is radical 2 over 2, okay? And then we're going to add the sine of 45, which is also radical 2 over 2, times the cosine of 30, which is radical 3 over 2. Okay, if we multiply these two things together, we get radical 2 over 4. And we're going to add, we get radical 6 over 4. And it's two fractions with a common denominator. So I would go ahead and add your two numerators. And we can say that the sine of 75 is equal to radical 2 plus radical 6, all of that over 4. Okay, that is the exact value of the sine of 75. Now, this should match up with that value in your calculator. Okay, so if you're in degree mode, which you may not be because we haven't been using degrees lately, but if you take the sine of 75 in degree mode, it's about 0.965, okay? If you take the square root of 2 and you add the square root of 6, and then you divide by 4, you're going to see that you also get about 0.965, okay? So that's where the exact value comes from, all right? Let's try a couple of others real quick here. Second one I want to try is cosine of 15, okay? So the cosine of a 15 degree angle. So you've got to find some combinations of angles that we know how to find. 30s, 45s, 60s, 90s. You could use a 135, you could use a 225, doesn't matter. Just two angles that you can either add or subtract to get 15, okay? I'm thinking 45 and 30. Okay, this is the same thing as the cosine of 45 minus 30, right? 45 minus 30 is 15, okay? So we're going to use the difference identity for cosine. And the difference identity says if I want to find the cosine of 45 minus 30, or the cosine of 15, I'm going to take the cosine of both angles first. So that's the cosine of 45 times the cosine of 30. Okay, now the weird thing here, for the difference identity for cosine, you actually add the two statements. So we're going to add sine of 45 and sine of 30, and we just put all this together. Cosine of 45 is radical 2 over 2. Cosine of 30 is radical 3 over 2. Okay, then we're going to take the sine of 45, which is radical 2 over 2. Sine of 30 is 1/2, okay? If we put all that together, we get radical 6 over 4 here. We get radical 2 over 4 here. So it's going to be radical 6 plus radical 2, all of that over 4. And you'll notice a lot of these values have a lot of the same numbers popping up in them, okay? So radical 6 plus radical 2 over 4. Oh, that's actually the same thing, I think, as the answer we got before. I'm going to check. Cosine of 15 is, in fact, 0.965, which turns out the cosine of 15 is the same value as the sine of 75. There's a reason, but we're not going to talk about it in this course. Well, other than what you just saw here. Okay, let's try one more example, and then I think hopefully at that point you'll have it. Let's try the cosine of 105 degrees. Cosine of 105. Okay, cosine of 105. So you've got to come up with a way to get a 105 by either adding or subtracting angle measures. If you think about it, how about 60 and 45? That would add up to 105. So that's going to be the cosine sum formula. That's the cosine of, and it doesn't matter. You can do 45 plus 60, or you can do 60 plus 45. You should get the same answer in the end. So you take the cosine of both angles, cosine of 45, cosine of 60. But for the cosine sum, you subtract. And it's going to be sine of 45, sine of 60. Okay? And if we put all this together, that's radical 2 over 2. That's 1/2 minus, this is going to be radical 2 over 2. And sine of 60 is going to be radical 3 over 2. Okay? So in the end, we're going to get radical 2 over 4 minus 6 over 4. So radical 2 minus radical 6 all over 4. Okay? If you remember, cosine is negative in the second quadrant, so I think that makes some sense. Cosine of 105 is about negative 0.258. Okay, if I take the square root of 2 and I subtract the square root of 6 and I divide by 4, I'm going to get that same negative 0.258. So again, a lot of these answers are going to look a lot alike. You're going to see a lot of radical 6s, a lot of radical 2s, a lot of 4s on the denominator. As you kind of mix these things around. And we know you're going to get lots of the same values because you can shift trig functions different directions and get other equivalent values. So you'll maybe see positive and negative signs change and those sorts of things. But a lot of things that are going to look a lot like this, okay? So I don't want decimal answers. I want the exact fraction values. Most of them will have radicals. Hopefully those examples will make things a little bit more clear for you.